Alright, so we're looking at lesson 8 today. We're going to be looking at friction. So hopefully after this lesson you'll understand how friction works. So the symbol F sub n represents the normal force, because in mathematics and physics the word normal means perpendicular. So we're going to be using this F sub n quite a bit throughout the year. For problems in this lesson, the normal force will have the same magnitude as the weight. In later lessons, we will look at problems where the normal force is not the same as the weight, but we are starting with basic problems right now. So the normal force is going to be the same as the weight. Whenever you have a block that rests on a table, a force with a horizontal component is required to get the block to move. I should say move here. And a horizontal force component is required to keep it moving. The force that resists the movement is called a friction force. And so we're going to be looking at that friction today. So read pages 38 and 39 in the textbook about friction and a moving block. And then once everyone is finished, y'all can look over it. But just kind of read through about your block on page 38 and 39. Alright, so we can find that the force required to start the block moving is a product of a constant that we call the coefficient of static friction. And this is mu sub s. And the total upward force that is perpendicular to the surface on which the block rests is called the normal force, F sub n. And we call the maximum force with which the block resists movement the force of static friction, F sub s. And this is the formula that we can use from those three variables. F sub s equals mu sub s, F sub n. So that's a formula you probably want to write down on your formula sheet. The minimum force required to keep the block moving is equal to the product of the constant that we call the coefficient of kinetic friction, mu sub k, and the normal force between the surfaces, F sub k, which is read F sub k. So this is your formula, F sub k equals mu sub k, F sub n. So your coefficient of static friction and coefficient of kinetic friction are two different things. If you've ever had to move a large object, you've probably found that once it starts moving, it's easier to keep it moving. And so that's because the static friction and the kinetic friction coefficients are different. The direction of your force of kinetic friction is always in the opposite direction to the direction of the motion of the object, because it's always pushing backwards. It's always trying to slow you down. Friction, you want it when you're driving, otherwise you would just slide off the road. But when you're moving something, sometimes you wish that you didn't have as much of it, but it is going in the opposite direction because it's slowing you down. It's resisting you. So the values of mu sub s and mu sub k are determined experimentally, and they're not exact. So if you go to another book or another scientist, they may give you different numbers just because they're not exact. They determine them just repeating experiments over and over again. So these two equations are not laws, they are just rules. They describe empirical relationships, and so they're not laws, they're just rules. But we like to use them because they help us with these problems. So let's look here. We have the coefficient of static friction between a 6,493 Newton block and the level surface on which it rests is 0.732. What is the horizontal force that must be applied to the block to make the block begin to move? So we want to know what is our F. Well, if you look, they tell us that F has to equal F sub s. Okay? And so we need to know what is going to make it move. Well, F sub s is the same thing as mu sub s F sub n. Okay, so it tells us that the coefficient of static friction, that's our mu sub s, is 0.732. And it says that we have a block that is 6,493 newtons. And so that is our F sub n. So we're going to multiply those two together. And I get 4,752.88. And how many sig figs are we going to have in our answer? Here we have 4. Here we only have 3. So we need to have 3 sig figs. So 4,750. And then force is measured in newtons. And so that would be your answer for that one. Okay, so you just use your formula that they gave you. We're going to look at one more example for friction. This one is dealing with kinetic friction. It tells us a block is being dragged across a level surface at a constant speed. Well, you want to find out the mass. So first we're going to have to figure out the force. So F is going to have to equal F sub K. And F sub K is mu sub K F sub N. So they tell us the coefficient of kinetic friction is 0.2, and the force that is being applied is 9,800. So that is our F. And we need to figure out our F sub N. So you're just going to do 9,800 divided by 0.42, and you get 2,333.3 repeating. So that's your F sub N. However, they want to know what is the mass. Well, if you look, F sub N and the M equals G are going to be balancing out. F sub N has to equal mg. So our F sub M is 23,333.33 repeating. We don't know the mass, and our gravity is always 9.81. So we're going to divide that number by 9.81, and I get a mass of 2,378.5. Here we only have 2 sig figs on both of these problems, so our answer can only have 2 sig figs. So 2, that 37 is going to round to a 4, and then 0, 0. And it's mass, so mass is kilograms. So there would be your answer for that friction problem. So you basically just have to look at the picture and use the formulas that they give you. They're not terribly difficult. They're just trying to get you to get used to setting forces equal to each other that are in opposite directions. Okay, so your homework tonight is 1 through 20, so make sure that y'all do those so that we can go over any questions you have.